Hi, today we are going to discuss spread, which is another part of how we're going to describe distributions. Remember in the last lesson we talked about shape and center. So after we've talked about the center, which is a typical value in the data set, then we'd like to know how spread out are the data. Like, are they all focused around a single value, or are they widely spread out where there's a wide range of values they could take on? So the definition of spread is it describes how similar or varied the set of observed values are from a particular variable. Similar would mean that they're maybe close to a certain value, and varied means they could be spread apart. Measures of spread include the range, quartiles, and the interquartile range, and the variance and standard deviation. The range is the easiest measurement of spread, and it is simply the maximum value minus the minimum value. Okay, and you do that subtraction and you get one single value. And that measures the overall dispersion of values in a data set, or the overall spread. On the AP exam, it's used a lot if we have to describe a graph, because it doesn't require a calculator to calculate that. It's a fast way to determine the spread of data. The interquartile range, or we will abbreviate it as IQR, is Q3 minus Q1. So it's the third quartile minus the first quartile. And that gives us the range of the middle 50% of the data. Okay, so it's very similar to the range above, but the regular range tells you how far it is from the lowest piece of data to the highest. In the interquartile range, we know from how far it is from the first quartile to the third, or the middle 50%. This is the preferred measure of spread if you have a skewed distribution. And remember, for a skewed distribution, we also like the median as the measure of center. Okay. Now, the standard deviation is another measure of spread, and that is the average spread of the data around the mean. Okay. It's best used for spread in unimodal symmetric distributions. So when we have a distribution that's a bell-shaped curve like this, that's unimodal symmetric, and we know that the mean is in the middle. The best way to describe that spread is to use this standard deviation. Okay. So when we have these unimodal symmetric distributions, we would use the mean as the center and the standard deviation as the spread. Now, the definition says the average spread of the data. So basically, we're going to figure out how far is each piece of data away from the mean. Okay. And then we're going to add all those up and find the average spread of that data. Okay. There are a couple little details that we have to do, a couple important parts. But there are two standard deviation equations, depending on whether your data comes from a sample or a population. And actually, those equations are below, and we'll talk about those in a second. The variance is another measure of spread, and that's the average squared distance of the data around the mean. And the way you get variance is you just square the standard deviation. And the variance is actually part of the formula for standard deviation. It's the stuff underneath the square root symbol. Okay? So it's before you take the square root. That's the variance. Okay? And this, let's talk about these equations for a second. Like we said, there's two equations. The one that starts with labeled S of x, that's the sample standard deviation, if your data comes from a sample. And the one that starts with this symbol, which is called sigma, it's a Greek letter, that's the population standard deviation. Okay. Just like before, for the mean, we had a sample mean and a population mean. We have two different standard deviations, depending on if you're looking at a sample of data or a population of data. If you look carefully, there's not much difference between these two formulas. In the sample formula, you notice that they have the sample mean. And in the population formula, you'll notice they have the population mean. The other difference, the biggest difference, is that in the population formula, we're going to, when we find our average, we're going to divide by n, which is our sample size. That's down here. Or in this case, the population size, if it's the population standard deviation. And on the sample standard deviation, we are going to divide by 1 less than the sample size. Okay, so we're going to divide by a little smaller number, which is going to give us a little bigger average. And that's the reason for that is it'll give us a little better estimate because we only have a sample of the data. We don't have all of the data. So when we have a sample, we're going to have just an estimate of the answer, not the real answer. Okay. I think the best way to learn about these formulas is to actually try them. Try one. So here's what we're going to do. We're going to try to find the sample standard deviation of these 5 numbers, the numbers 1, 2, 3, 4, 5. Okay. And then we'll keep referencing the formulas above. So when you're doing this by hand, it's a good idea to start with just a list of the numbers. Oops, there's not a 0 in there, sorry. So I have 1, 2, 3, 4, and 5. And then from what you know about order of operations, the first thing we should do is the stuff that's in parentheses. And we're going to do the sample standard deviation here. So I'm doing the first formula. So the first thing we would do is take each piece of data and subtract the mean from it. So I would need to know what the mean is. So part of this is I would have to add these up and divide by 5, because there's 5 numbers. So that would be 9, 10, 11, 12, 13, 14, 15. Divided by 5, the average is 3. Okay, or the sample mean is 3. So the first step would be take each x and subtract this mean. So it'll be 1 minus 3, 2 minus 3, 3 minus 3, 4 minus 3, and 5 minus 3. Okay, so these numbers are the data. Use my highlighter here. And then I'm subtracting the mean that I just found from each one. So I'm going to do that. And that'll give me -2, -1, 0, 1, and 2. Okay, so those are the distances away from the mean. And we said it's the average distance away from the mean. So it might make sense to you to say, all right, I'm going to add these up and get the average. Well, if you add these up, you'll notice that they add up to 0. So if I took that and then divided by 5, I'd still get 0. And I think you would agree that the average spread of this data is not 0. Okay. If you find the spread to be 0, it means the data is all the same point. So it'd be like all 3s. Okay. So this is a problem because this happens with every set of data. Okay. If you subtract the mean from each piece of data, they cancel each other out all the time. So if you go back up to the formula, that's why we do this squared, okay? Because squaring takes all of these numbers and makes them positive. So the next step in this, after I found all the distances, is to square all those distances. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. Now I can add them up. And in the formula, that's what this means. If you look up at the top, towards the top of the slide, that sigma symbol, that's the capital sigma, that's the summation symbol. That means add up whatever comes after it. So I'm going to add these up. 4 plus 1 plus 0 plus 1 plus 4 is 10. So that is the top of this fraction is the 10. Okay. And then I'm going to divide by n minus 1, and the n is the sample size. And since there were 5 numbers in my sample, I'm going to divide by 5 minus 1, which is 4. So it'll be 10 divided by 4. And that is 2.5. Okay? So that 2.5 is what would be under the square root sign. Okay? This 2.5, though, has a special name. It's called the variance. Okay? It's the average squared distance from the mean, okay? And it's squared because it comes from squaring all of these values, okay? Because remember, if I didn't square them, when I added up those differences, they would cancel out to 0. And to avoid that, we square all of them, which means that this measure of spread is a squared measure of spread, okay? It's not in the original units of the problem. You can think of it as if the original units of the problem were like feet, then I just found the variance, which would be feet squared, okay? So that's the variance. To get it back to the original units of the problem is why we do the square root of that, okay? So that's why at the end of this problem, we take the square root of 2.5, which is 1.58. Okay, that is the sample standard deviation. So we would say that this data has an average spread around the mean of 1.58. Now that's the sample standard deviation, okay? The only difference in our calculation, if we had a population standard deviation, is at this step right here. Instead of dividing by 5 minus 1, we would just divide by 5. Because remember in the population standard deviation equation, we just divide by n. Okay, so 10 divided by 5 would be 2. Now I haven't taken the square root yet, so this 2 would be the population variance. Okay, and to get it to the standard deviation, I would have to take the square root of 2, which is 1.41. Okay, so the formula you use would really be dependent on whether you have a sample of data or a population of data. Okay, the things to remember about this formula, try to remember that it's the average spread of the data. So every single piece of data, I'm going to find out how far away it is from the mean. Remember that, so every piece of data counts. And remember that we have to square the differences because the differences will cancel out if we don't. And our first answer before the square root is called the variance, okay? And then once we take the square root, we get back to the original units of the problem, and that is the standard deviation, okay? So remember also to go back and forth between the standard deviation and the variance is simply a matter of squaring or square rooting. So if you square the standard deviation, you get the variance. If you take the square root of the variance, you get the standard deviation. Okay. Now, lucky for us, you do not have to do this by hand. Our calculators do this calculation. So on your calculator, we're going to do stat, edit, and L1. Just like we entered data to calculate the mean, just like we entered data to do a histogram, that's how we start the process. So hit stat, edit, and enter the numbers 1 through 5 into L1. So it'll look like this. Okay, this first screen, the upper left, you'd have all of your data in L1. Then on the stat menu, so I hit stat again after I've entered the data, you're going to actually move over to calculate, okay, just like we did before. And then we're going to do the one variable stats calculation. Same place we went to find the mean and the median, okay? So the next screen, you just make sure it says L1. Then you hit enter, and you will get this screen right here. And I'm going to zoom in a little. You'll notice they give you both standard deviations. So this is the sample standard deviation, and this is the population standard deviation. Notice they're the same values we got on the previous slide. We got a sample of 1.58, and we got a population of 1.41. Okay. The calculator doesn't know when you enter a set of data into L1 if you've entered a sample or a population. So instead of asking you, it just computes both. So you just need to be careful that you choose the correct one. And how do you know the correct one? You have to read the question carefully and see if they asked you for the sample or the population. Okay. So from now on, we expect you to use your calculator if you're asked excuse me, to find the standard deviation. Okay. If I asked you to find the variance, you would use the calculator as well, but you would square these values. Okay. So if you square them, they become variance. Okay, so just remember that. Sorry, become doesn't look very good. As far as other measures of spread, remember you can use the range, and that's just the max minus the min. So on this, you could use our calculators and find the max and the min, and just do 5 minus 1 is 4. The interquartile range would be subtracting Q3 minus Q1, and those are up here too. Q3 is 4.5, and Q1 is 1.5. So 4.5 minus 1.5 is 3. So that's the IQR. Okay. So I can get those right off the screen. And keep in mind that for unimodal symmetric distributions, so distributions that look like this, to the right here, you're going to use the mean and standard deviation to describe the distribution. The mean would be the center, and the standard deviation would be the spread. For skewed or irregular distributions, so if you have a distribution that looks like this, skewed left, or if it looks like this, skewed right, then we're going to use the median and the IQR to describe the distribution. The median would be the center, and the IQR would be the spread. Okay. On the next slide, what we're going to do is we're going to describe the shape of each distribution on the next slide, and what measurements would you use to describe the center and spread. So our first distribution here, it says, how would you describe the distribution of ratings of 25 internet cats? So this must be a popularity rating of some kind. Notice that the graph starts out really high on the left, or on the right, and then gets lower and lower as we go to the left. This means that the graph is skewed left towards that tail. Remember, the tail's down here. And in a skewed distribution, we would use the median as the center, and the IQR as the spread. Okay, and that would be the same thing if this had been skewed right. We would have also used the median and the IQR. This distribution is the daily high temperatures in Edgerton, Iowa in July. And these are in Celsius, obviously, because in July it's hot. And again, if you just draw a little loose line around these peaks, you'll see that this distribution is unimodal symmetric. Okay, and in a unimodal symmetric distribution, we use the mean as the center, and we use the standard deviation as the spread. Okay, and this is stuff that you have to memorize. You have to know the different shapes, and then when to use the mean, when to use the median, and when to use the IQR, and when to use the standard deviation. Okay, so good luck with your spread homework.